What are these first order circuits? They are basically the RC and the RL circuits. Okay, RC and RL circuits are called as what? First order circuits. Okay, so let's consider a simple RC circuit. A resistor in series with a capacitor R in series with C, and let R and C be connected in series with a voltage source which is some Vs, and let the variable of interest be what? Vc. So we have what? A simple RC circuit, R and C in series, voltage across the capacitor is what? Vc, and that is the variable of interest, that is the variable or the output quantity of interest, connected across what? A voltage source Vs. This voltage source can be any type of voltage source. Okay, it can be DC, it can be AC, it can be any type of voltage source. Is it not a single loop circuit? This circuit, it is what? A single loop circuit. Now let us find the equation for the variable of interest, that is what? Vc. And if we solve that equation, we will be able to get Vc as a function of time. But to find Vc as a function of time, you should get an equation that contains what? Only Vc. So let us try to get that equation which contains what? Vc. Okay. Now let IC be the current through the capacitor. If the current through the capacitor is what? IC, because the resistor and the capacitor both are in series, even the current through the resistor is going to be what? The same IC. And then let the voltage across the resistor be some VR. So just like Vc is what? Voltage across the capacitor, VR is what? The voltage across the resistor. Okay. And can't we express the current through the capacitor in terms of the voltage across the capacitor? You know, I is equal to what? C times dVc by dt. IC is equal to what? C times dVc by dt. Now around this loop, can't we write KVL? In a single loop circuit, the only thing we can do is what? To write KVL around the loop. So what do you get if you write KVL around the loop? The applied voltage Vs will be equal to what? The voltage across resistor plus the voltage across the capacitor. Okay. So if you write KVL around this loop, you will get VR plus Vc equal to what? The applied voltage Vs. I mean, there is also what? Some type of voltage division. The applied voltage will definitely get divided between the resistor and the capacitor. So Vs is equal to what? VR plus Vc. Now the voltage across any resistor is what? Ohm's law, current into resistance. What is the current? IC into resistance is what? R. So VR, is it not IC into R? And then Vc, we'll write it as Vc itself, and right hand side is what? Vs. But you know, IC is what? C into dVc by dt. So in this equation, in the first term, in place of IC, let us write C dVc by dt, and then IC is what? Getting multiplied with R. So if you multiply IC with R, won't you get RC dVc by dt plus Vc equal to Vs? That's all. This is the differential. Is it not a differential equation? That's on RC dVc by dt plus Vc equal to what? Vs. What is the only unknown or variable in this equation? Remember, in the given circuit, the value of resistance, the value of capacitance, and also the value of the input source Vs, all are going to be known or given values. Okay. So R is known, C is known, Vs is also known. The only thing unknown is what? Vc. So how many unknowns we have? One unknown, Vc, and we also got one equation. One unknown, one equation. We can solve for Vc. So this is the equation governing this RC circuit. So what kind of equation is it? Is it not a differential equation? Now you know, for every differential equation, won't there be an order? For every differential equation, there is going to be something called order. What is the order of this differential equation? Is it not a first order differential equation? Order is related to what? The highest degree of the derivative. Highest derivative that is involved. Okay, highest derivative is what? dVc by dt, first derivative. If it contained what? d square Vc by dt square, then highest derivative is what? The second derivative. Then the differential equation will be called as what? A second order differential equation. But for now, our circuit is governed by what? A first order differential equation. Okay, so this is what? A first order differential equation. Because the circuit is what? Governed by a first order differential equation, this circuit will be called as what? A first order circuit. That's all. Because the circuit is what? Governed by a first order differential equation, this circuit will be called as what? A first order circuit. That's all. So what will decide the order of any circuit? It is the order of the differential equation. What will decide the order of any circuit, where it is first order or second order or third order and so on? It is the order of the differential equation governing the circuit that will decide the order of the circuit itself. Okay. Now for this circuit, the governing equation is what? A first order differential equation. Even the circuit will be called as what? A first order circuit. So for the RC circuit, what is the differential equation governing the circuit? RC dVC by dt plus Vc equal to what? Vs. Okay. And if you solve this differential equation, you will obviously get Vc as a function of time, and you know how to solve any differential equation. Yes. So once again, you can see I have drawn the same RC circuit driven by some source Vs, and the variable of interest is what? Vc. Already we derived the differential equation for this circuit, which goes as what? RC into dVc by dt plus Vc equal to what? Vs. Now let us understand how this RC circuit will behave when there is no source driving the circuit. Let us understand the behavior of this RC circuit if there is no source driving the circuit. That is what? The source free case. Understood, right? Let me write it. Let us understand the behavior of a source free RC circuit. What is it? Source free RC circuit. What is the meaning of source free? The meaning of source free, it means what? The value of the source is what? 0. When I say source free, there are no independent sources. When I say source free, there are no independent sources that are driving the circuit. In this circuit, there is only one independent source, that is what? Vs. And when we say it's a source free RC circuit, that independent source, it becomes what? 0. As I wrote here, Vs becomes 0. When Vs becomes 0, what about the differential equation governing the circuit? Again, take the differential equation, just put Vs equal to what? 0. If you make Vs 0, it is right hand side, that will become what? 0. That's all. So RC dVc by dt plus Vc equal to what? 0. Otherwise, it would have been Vs on the right hand side, but because we are only considering a source free case where the source value is what? 0, Vs becomes what? 0, then there is the differential equation governing the circuit. Still it is what? A first order differential equation. In fact, this is called a homogeneous first order differential equation. Nevertheless, it is still a first order differential equation. RC dVc by dt plus Vc equal to what? 0. Now let us say, so when the source becomes 0, by the way, the source is what? A voltage source. If any voltage source becomes 0, does it not become a short circuit? Yes or no? In this circuit, if you make the source 0, that means what? The voltage source, you are making it 0. If you make the voltage source 0, that voltage source becomes what? A short circuit. Okay. Then how will the circuit look like? The circuit, does it not look like this? Yes or no? When this voltage source becomes a short circuit, all that is left in the circuit are what? The resistor and the capacitor. Okay, this is what? R, this is what? C. Voltage across the cap is what? Vc. Or let me write it slightly differently. RC, voltage across the cap is what? Vc. Now in this source free RC circuit, this is what? A source free RC circuit. Two things. Okay. Number one, R and C both are in parallel. They are not only in parallel, they are also in series. Yes or no? Whatever current flows through R, the same current will flow through what? the capacitor as well. And whatever voltage we have across the capacitor, the same voltage will also be present across the resistor. Because it's a two element circuit, the two elements will be both in series as well as parallel. Series means what? Current will be same. Parallel means what? The voltage drop also will be same for both the elements. Okay. Now let us understand how this source free RC circuit will behave. Okay. So I have drawn the RC circuit again. Drop across the capacitor is what? Vc. Drop across the capacitor, let it be some Vc. Now let us say this circuit starts at t equal to 0. What is it? This circuit, let it start at t equal to 0. Okay. I'll repeat myself. This circuit, it starts at t equal to 0. That means what? At t equal to 0, resistor is connected across the capacitor. Okay. And again, anything can happen to the capacitor before t equal to 0. That is like the history of the capacitor. Okay. Circuit starts at t equal to 0. And let us say Vc of 0. What is this Vc of 0? Is it not the initial voltage across the capacitor? Yes or no? For any capacitor, the initial condition is what? The initial voltage across the capacitor. And for any inductor, the initial condition is what? The initial current through the inductor. For inductor, it is what? The initial current. For capacitor, it is what? The initial voltage. So in this circuit, there is one capacitor. And for this capacitor, let the initial voltage be some 10 volts. You can consider any value, but let us consider 10 volts to be the initial voltage across the capacitor. Okay. So given that the capacitor has an initial voltage drop of 10 volts, how will this circuit behave for t greater than 0? Let us understand. Let us understand what happens for t greater than 0. Let us understand what happens for t greater than 0. In fact, we'll try to answer this question like what happens in the circuit for t greater than 0. Okay. Let IC be the current through the capacitor. Let IR be the current through the resistor. Let IC be the current through the capacitor. Let IR be the current through the resistor. Please type in the chat box what is the relation between IC and IR. Please type in the chat box the relation between IC and IR. What is the relation between IC and IR? Quickly. IC equal to minus IR. Yes. Both the currents are negative of each other. Both the currents are negative of each other. Yes. Okay. Uday vachava. IC equal to what? Minus IR. Because, very obvious, okay? Current through resistor, it will again flow through what? Capacitor. Yes. Current through resistor will flow through what? Capacitor in the upward direction. IC is what? Flowing through the capacitor in the downward direction, whereas IR will flow through the same capacitor in the upward direction. Both the currents are flowing in the same branch in the opposite direction. Both the currents are going to be negative of each other. So as you all said, IC equal to what? Minus IR. Very good. IC equal to what? Minus IR. Now at t equal to 0, at t equal to 0, can you tell me what is the value of IR? What is the value of IR? IR is what? Current through R. Current through R will be equal to what? Voltage drop across R divided by R. Voltage drop across R is what? Same as voltage across the capacitor. Because we are looking at the circuit at t equal to 0, IR will it not be equal to Vc of 0 divided by R? But I already told you that the initial voltage across the cap is what? 10 volts. So Vc of 0 is what? 10. So is it not 10 volts divided by R? IR is what? 10 volts divided by R. Okay. Now look at, so this 10 volts by R, is it positive or negative? 10 volts divided by R. 10 volts is what? Positive. Resistance always positive. So IR, it is what? Positive. IR is what? Positive. So IR is positive. Now look at this IR with respect to capacitor. With respect to capacitor, IR, does it not flow out of the plus terminal? Please recognize that with respect to capacitor, IR flows out of the plus terminal. Please look at the circuit. You will clearly be able to identify that IR, it flows out of the plus terminal. You know, for every capacitor or for any capacitor, if a positive current, by the way, this IR is what? Positive. If a positive current flows out of the plus terminal, will the cap get charged or discharged? Please type in the chat box. If a positive current flows out of plus, will the cap get charged or discharged? Positive current flowing into plus, cap will get charged. Positive current flowing out of plus, cap will get discharged. Obviously, cap is going to get discharged through the resistor. Okay. So because of this IR, the capacitor, it starts getting discharged through what? The resistor. The capacitor, it starts getting discharged through the, through the resistor. Capacitor starts getting discharged through the resistor, because see, it is very simple. The moment you connect the resistor across the capacitor, the resistor will start drawing current. Yes or no? The moment you connect resistor across the capacitor, resistor starts drawing current, and whatever current will be drawn by the resistor, that current will be actually drawn from the capacitor. If you draw current from a capacitor, cap will get discharged. Okay. So here also same thing will happen. Now when the cap starts getting discharged, what will happen to Vc? Will it not start decreasing? Vc will start decreasing. Okay. So this means Vc will start decreasing. Vc will start decreasing. Can you tell me the rate of change of the voltage across the cap? Okay, question number 1. dVc by dt, is it going to be positive or negative? Will it not be negative? Because already we know cap is what? Getting discharged. Cap getting discharged, it means what? Vc will decrease. Decreasing, that means what? Rate of change will be negative. Charging, getting charged, Vc will increase. Vc increasing, then the rate of change will be what? Positive. So here definitely dVc by dt is going to be negative. Always for a capacitor, you know, dVc by dt, is it not equal to IC by C? Always for a capacitor, dVc by dt, it is what? IC by C. Always for a capacitor, dVc by dt is what? IC by C. But in the very beginning, you only said IC is what? Minus IR. So in place of IC, we can write what? Minus IR again divided by C. And at t equal to 0, that is what? Initially. At t equal to 0, that is what? Initially, because circuit starts at what? T equal to 0. T equal to 0 is also called as what? The initial state for the circuit. Okay, so initially, what is the current through the resistor? It is 10 by R. IR is what? 10 by R. Minus IR by C, will it not be minus 10 by RC? So as we expect, the rate of change of voltage drop across the cap, it is indeed negative, because only if it is negative, Vc will decrease. In other words, the cap will get discharged. So what is the rate of discharging for the capacitor? If I ask you, what is the rate of discharging or the rate of decay of the capacitor voltage, what will you say? What is the rate of discharging for the capacitor? What is the rate of decay of the capacitor voltage? How much is the rate of decay? What is the rate of decay? Shivasainath is saying minus 10 by RC. Dineshwaran also says minus IR by C, right? How is it IR by RC? It should be IR by C, rate of decay. What about others? If I ask you what is the rate of decay of the capacitor voltage, will you say minus 10 by RC? Rate of decay. Now you understood why I am asking this question. You should not say minus 10 by RC. You should not say minus 10 by RC. Already I am saying what? Rate of decay. When I use the word decay, it is understood that VC will decrease with time. Again, rate of decay cannot be negative. Rate at which capacitor voltage will decrease will be what? Positive. Rate of change is what? If I ask you what is the rate of change of capacitor voltage, then you should say what? Minus 10 by RC. Because rate of change is what? Simply dVC by dt. dVC by dt is what? Minus 10 by RC. But if I ask you what is the rate of decay, it is understood that there is this minus sign. Again, in your answer, you should not say minus 10 by RC. When I ask what is the rate of decay, you should simply say 10 by RC. I hope this simple point is clear. Yes. Rate of decay, it is what? 10 by RC. Rate of change is what? Minus 10 by RC, because rate of change is what? Negative. Rate of change negative, it means what? It is decreasing, or there is going to be decay in the capacitor voltage. Okay. So rate of decay, you should not include minus sign in your answer. You should simply say 10 by RC. Okay. So here the rate of decay, it is what? 10 by RC, not minus 10 by RC. Okay. So is it clear up to this point? So when the resistor is what? Connected across the capacitor at t equal to 0, then the resistor will start drawing current from the capacitor, which means the capacitor will start getting discharged through the resistor, and the initial rate of decay is what? 10 by RC. So after some time, the voltage across the capacitor will be 10 or less than 10, because VC is what? Starting to decrease. After some time, VC will become less than 10. Let us say at some time instant t1, which is greater than 0, let the voltage across the cap decrease to what? Some 8 volts. Okay. Clear up to this point? Yes. Again, I have drawn the same circuit. Capacitor, it is now getting discharged at some time t1. At t equal to t1, let the value of VC reduce to what? 8 volts. What was the initial voltage across the cap? 10 volts. And after some time, let the value of voltage reduce to what? 8 volts. If VC is what? 8 volts, can you tell me what is the current drawn by the resistor? Always the current drawn by the resistor will be equal to what? Voltage across the cap divided by resistance. Now the voltage across the cap is what? 8. So is it not 8 volts divided by R? It is what? 8 volts divided by R. Now again, what is dVC by dt going to be? What is dVC by dt going to be? Always dVC by dt, that is what? Rate of change of voltage across the cap, is always equal to what? IC by C. And in this circuit, always IC is equal to what? Minus IR. So this is equal to what? Minus IR divided by C. And at t equal to t1, the current through the resistor is what? 8 by R. So minus IR divided by C, is it not minus 8 by RC? So now what is the rate of decay? Now what is the rate of decay? Tell me, at t equal to t1, at t equal to 0, what was the rate of decay? 10 by RC, yes or no? Initially, at t equal to 0, what was the rate of decay? 10 by RC. After some time, let us say at some t equal to t1, now what is the rate of decay? Did you say 8 by RC? Yes, very good. Now the rate of decay is what? 8 by RC. Yes, so what happened to the rate of decay? Did it increase or decrease? Initially rate of decay is what? 10 by RC, and now at t equal to t1 the rate of decay has become what? 8 by RC. From 10 by RC it has reduced to what? 8 by RC. Okay, clearly rate of decay, it is what? Decreasing. It should decrease because the rate of decay, it directly depends on how much current is drawn by the resistor. Initially when Vc is what? 10, current drawn by the resistor is what? 10 by R. Now the current drawn by the same resistor is what? 8 by R. Current drawn decreases, even the rate of decay will decrease. Okay, anyway, and then let us say at some later point in time, and by the way, this t1, it is obviously greater than 0. Now at some later point in time, let the value of Vc become equal to what? 5, because Vc is what? Vc will further decrease. Already at t equal to t1 it has become what? 8. Now at some later point in time, let it further reduce to what? Some 5 volts. It is like this. Initially it is what? 10. From 10 it has reduced to what? 8. From 8 it has further reduced to what? 5. Okay, and even this t2 will be what? Greater than t1. And if Vc reduces to what? 5, now what is the current drawn by the resistor? What is the current drawn by the resistor? Will it not be 5 volts divided by R? Now what is the rate of change of the capacitor voltage? Always dVc by dt is what? Ic by C, and Ic is what? Like minus IR by C, and IR is what? 5 by R. So minus IR by C, will it not be minus 5 by RC? Yes. So now what is the rate of decay? At t equal to t2, what is the rate of decay? Is it not 5 by RC? At t equal to 0, what was the rate of decay? 10 by RC. After some time, at t equal to t1, what is the rate of decay? It has become 8 by RC. And after some time, at t equal to t2, what is the rate of decay now? It is 5 by RC. Look at the rates of decay. 10 by RC decreases to what? 8 by RC, again decreases to what? 5 by RC, and so on. So clearly the rate of decay is what? Reducing with time. So as time progresses, the rate of decay is what? Reducing with time. 10 by RC down to what? 8 by RC, again down to what? 5 by RC, and so on. So now tell me, in this way, how long will the cap get discharged? The cap will continue to get discharged as long as resistor is drawing current from the capacitor. Listen carefully. Cap will continue to get discharged as long as resistor is drawing current from the capacitor. So when the resistor stops drawing current from the capacitor, then the current through the capacitor becomes 0. Yes, when the current through the capacitor becomes 0, current through capacitor 0, even the voltage drop will become what? Constant. But when will the current drawn by the resistor become 0? Current through any resistor becomes 0 when the voltage drop across the resistor becomes what? 0. Now for the current through resistor to become 0, it is the voltage drop across capacitor that should become what? 0. So as the value of Vc keeps on decreasing, 10 down to what? 8, down to what? 5, down to what? 3, 2, 1, and finally Vc will become what? 0. Yes. So after some time Vc will become what? 0. When the voltage across the cap becomes 0, then the resistor will not draw any current. Then the cap will stop getting discharged. In fact, Vc will remain at 0. Vc 0. That means what? Voltage across the cap is what? 0. Voltage across the cap 0. What is the energy stored in the capacitor? 0. Yes, on voltage drop across the cap, after a long time, it becomes what? 0. If the voltage drop across any cap is what? 0, then the energy stored in the cap, it becomes what? 0. Energy stored in the cap 0, that means what? Cap is now fully discharged. So in this way, as the capacitor voltage continues to decrease, After some time, what is it? After some time, Vc approaches what? 0. Yes, when Vc approaches 0, then the current drawn by the resistor also approaches what? 0. If the current through the resistor is what? 0, even the current through the capacitor, it becomes what? 0. If the current through the capacitor becomes 0, then charging or discharging will not take place. Vc will become constant. Okay, so this means Vc will become constant. But already Vc has become what? 0, and now Vc remains what? Constant. That means what? Vc will remain at 0. Vc will remain at 0. Vc remains at 0. That means what? Cap has now gotten fully discharged. Okay. Cap is now fully discharged. Cap is now fully discharged. Understood? That's all. So what happens in this source-free RC circuit? Initially, there will be some voltage across the capacitor. You see, initially, if there is voltage across the cap, it also means what? Initially, there is some energy stored in the capacitor. Okay. In fact, in this particular example, what is the initial voltage across the cap? It was 10 volts. Okay. So what is the initial energy stored in the capacitor? Half into C into 10 square. 10 square is what? 100. 100 by 2 is what? 50. 50 C joules. 50 C joules. That is the initial value of the energy stored in the capacitor. And slowly this resistor will start discharging the capacitor, due to which the capacitor voltage will continuously decrease with time. And after a long time, the cap will get fully discharged. When the cap gets fully discharged, the voltage across the cap, it becomes what? 0. Then the current, then the energy stored in the capacitor also becomes what? 0. So what happened to this initial energy that was stored in the capacitor? All that energy got dissipated by the resistor in the form of what? Heat. So as the cap gets discharged through the resistor, it is the energy in the capacitor that is already stored that will be dissipated by the resistor in the form of what? Heat. So after a while, all the energy that is stored in the capacitor will have been dissipated by the resistor. There is no more energy left in the capacitor for the resistor to dissipate in the form of heat, and that is when the voltage across the cap, it becomes what? 0. If the voltage across the cap is what? 0, current through the resistor is also what? 0. Current through the resistor 0, then the current through the cap is also what? 0. So after a long time, in this source-free circuit, can I say all currents and voltages will become 0? So in general, in a source-free circuit, because there are no independent sources driving the circuit, after a long time, when the circuit reaches what? Steady state, all currents and voltages will become what? 0. Why? Because whatever energy is what? Initially stored in the capacitor, that will eventually get dissipated by the different resistors in the circuit. Like in this case, this R will completely dissipate the initial energy that is stored in the capacitor, so that when the circuit reaches what? Steady state, no energy is left in the circuit. Without any energy in the circuit, current cannot flow. All currents will be 0. If all currents are 0, even all voltage must be 0. You understood? Yes. So for this circuit, if you try to plot the voltage across the capacitor versus time, if you try to plot the voltage across the capacitor versus time, what is the initial value of Vc at t equal to 0? The value of Vc is what? 10. Okay, and then starting from 10 volts, initially what was the rate of decay? 10 by RC. In fact, the slope dVc by dt, is it not the slope of the voltage waveform? And what was the slope? Minus 10 by RC. So it will do something like this. Okay, let this be T1, and then from T1 to T2, I think what was this voltage? It was 8. It was what? 8. And let this be T2. From T1 to T2, will it not decrease from 8 to 5? Yes, it will decrease from 8 to 5. So the point to be noted here is what? Initially the rate of decay is what? Maximum 10 by RC. From 10 by RC it became what? 8 by RC. Then it became what? 5 by RC. It will become like this and like this. Understood, right? So after a long time it will eventually touch what? 0. It will eventually touch 0. So the point that you should understand is what? In this RC circuit, the rate of decay or the rate of discharging, it is not uniform. It will decrease with time. Initially the rate of decay is what? Maximum. Thereafter the rate of decay, it keeps on decreasing. Okay, but in general you won't get this straight lines. It will be a smooth variation from its initial value of what? 10 to its final value of what? 0. Okay, finally it will become what? 0. We see when the cap is what? Fully discharged, it will become what? 0. So in reality you will get something like this. So look at the yellow color thing. Look at the yellow color thing. Is it not some type of exponential decay from its initial value of what? 10 volts to its final value of what? 0. Yes. So here is what? There is what? Exponential decay. Understood? So what is that differential equation for this source-free RC circuit? RC dVc by dt. In general, it is what? RC dVc by dt plus Vc equal to what? Vs. But here it is simply RC dVc by dt plus Vc equal to what? 0. RC dVc by dt plus Vc equal to what? 0. Now let us try to get an equation for this Vc variation as a function of time. Okay, RC dVc by dt plus Vc equal to 0. In fact, what are the dimensions of RC? What are the dimensions of RC? Please type in the chart box. What are the units for RC? What are the units for RC? Should it not be time? Should it not be time? Time, right? Yes. Because see, RC into dVc by dt. What is the meaning of dVc? dVc means what? Change in voltage across the cap. dt means what? Length of the time interval. Okay. Now RC into dVc by dt plus Vc. Vc is what? Voltage. If Vc is what? Voltage, even the first term must be what? Voltage. Now this RC is getting multiplied with voltage by time. RC gets multiplied with voltage by time. And you want this entire thing to be what? Voltage. That means what? RC should be time. So that RC is what? Time. dt is also what? Time. Time and time will get cancelled. Only dVc is left, which is what? Change in voltage, which is also what? Voltage. So dVc is what? Voltage. Vc is also what? Voltage. You can add or subtract two voltages. So the point is what? By looking at the equation, we can, come to a conclusion that RC should be what? Some kind of time. RC must be what? Some kind of time. And you already know that RC is called as what? Time constant. RC is what? Called as time constant of the circuit. Okay. So this RC, it is called as what? The time constant of the circuit. RC is called as what? The time constant of the circuit. And you know, time constant is what? Denoted by tau. Time constant is what? Denoted by tau. In fact, any first order circuit, every first order circuit is characterized by a time constant. Any first order circuit is characterized by a time constant. And for the simple RC circuit, tau happens to be RC. more on the time constant sometime later. Okay. Anyway, RC is what? The time constant, which means this differential equation can be written as what? Tau times dVc by dt plus Vc equal to what? 0. And then this can be written as what? Tau times dVc by dt equal to what? Minus Vc. Correct, right? Vc, I sent it across to the other side. It became what? Minus Vc. Now this Vc will come to the left hand side and dt will go to the other side. I will not going to get dVc by Vc is equal to what? Minus dt divided by tau. Tau goes to the other side, dt also goes to the other side, Vc will come to the left side. dVc by Vc is equal to what? Minus dt by tau. Okay. So what is it? dVc by dt equal to what? Minus dt by tau. Let us just perform indefinite integration on both the sides. So as you can see, I am not substituting any upper limit and lower limit for the integral. We are just performing what? Indefinite integration. What is the integration of dVc by Vc? Integration of dVc by Vc, it is what? ln of Vc. Integration of dVc by Vc is what? ln of Vc. And tau is what? Constant. Tau is what? Constant. In fact, tau is what? Time constant, which is equal to what? R into C. R is constant, C is constant. R into C is also what? Constant. So minus 1 by tau will come out. Integration of dt is what? Simply t. So ln of Vc is equal to what? Minus t by tau. ln of Vc equal to what? Minus t by tau. Is it complete or something must be added? Because we are doing what? Indefinite integration. You should always add a constant of integration. Let it be denoted by k. Now how do you find the constant of integration? You know, we know the initial voltage across the capacitor. We know the initial voltage across the cap. What is that initial voltage across the cap? Vc of 0, it is what? 10 volts. In the very beginning I told you what? The initial voltage across the cap is what? 10 volts. So using this initial voltage across the cap, let us get the value of k, for which you have to take this, you know, equation ln of Vc equal to what? Minus t by tau plus k, and then you substitute t equal to what? 0. Then left hand side will be what? ln of Vc of 0 equal to what? If you put t equal to 0, 0 by tau is what? 0 plus k. That's all. So k is what? K is what? ln of Vc of 0. K is what? ln of Vc of 0. Okay. Now come back to this equation. ln of Vc equal to what? Minus t by tau plus k, where k is what? ln of Vc of 0. Now this ln of Vc of 0 will go to the other side. Won't we get ln of Vc minus ln of Vc of 0 equal to what? Minus t by tau. Is it not like left hand side? Is it not like ln A minus ln B? ln A minus ln B is what? ln of A by B. So left hand side it can be written as what? ln of Vc of t. Remember, when I write Vc, it is understood that it is what? Vc of t. So ln of Vc of t divided by Vc of 0 equal to what? Minus t by tau. Now how do you get rid of the ln thing? You take e power on both the sides. You take e power on both the sides. Won't you get Vc of t by Vc of 0 equal to what? E power minus t by tau. That's all. Vc of t by Vc of 0 is what? E power minus t by tau. Now you send Vc of 0 to the other side. We get the final thing. That is what? Vc of t equal to what? Vc of 0 into e power minus t by tau. Okay. This is the final solution for Vc of t in our source free RC circuit. Please note it. Vc of t is what? Vc of 0 into e power minus t by tau. Okay, let me write it in the next slide. So So what did we get for Vc of t? Vc of 0 into e power minus t by tau. I mean, how do you interpret this expression for Vc of t? See here, at t equal to 0, if you put t equal to 0, e power 0 is what? 1. Vc of 0 into 1, Vc will be what? Vc of 0, it should be Vc of 0, it should be what? Vc of 0. And if you put t equal to what? Infinity. If you put t equal to what? Infinity. If you put t equal to infinity, what is e power minus infinity? 0. Vc of 0 into 0 will be what? 0. So what is happening in this circuit? As we already know, the value of Vc starting from its initial value, it will exponentially decay to 0 because the cap is what? Getting discharged through the resistor. The voltage across the cap will exponentially decay from its initial value of what? 10 volts, that is what? Vc of 0 to what? 0. Okay. So here, if you draw the waveform for Vc, that is what? Plotting Vc versus t, won't you get this thing? This is what? Vc of 0. So from Vc of 0, it will exponentially decay to what? 0. From its initial value, that is what? Vc of 0, it will exponentially decay to what? 0. Understood? Yes. And what is the initial rate of decay? What is the initial rate of decay? Initial rate of decay is what? 10 by Rc, and 10 is what? Vc of 0. So initial rate of decay is what? Vc of 0 by Rc, that is what? Tau. Let me write it separately. Initial rate of decay, it is what? 10 by Rc, and this 10 is nothing but Vc of 0 divided by Rc. And remember, Rc is what? The time constant. Rc is what? The time constant. Okay. Or if I ask you, what is dVc by dt at t equal to 0? What is dVc by dt? When I say rate of decay, it is what? Rate of decrease. But when I say dVc by dt, it is what? Rate of change. Rate of change is what? Negative, because cap is what? Getting discharged. dVc by dt at t equal to 0, it is what? Minus 10 by Rc, which is minus Vc of 0 by tau, which is what? Minus Vc of 0 by tau. So look at the rate of change, it is what? Negative. Now already we have drawn the waveform for Vc. Already we have drawn the waveform for Vc. Now at t equal to 0, if you draw a tangent at t equal to 0, if you draw a tangent to this exponentially decaying curve, yes. So what is this yellow color line? It is what? Tangent to this exponential curve drawn at t equal to 0. Yes, all of you know about tangent, right? Now if you look at the tangent, does it not intercept the time axis? Yes. In fact, this tangent will always intercept the time axis at tau. Yes. So if I simply give you the curve, and if I tell the value of this time instant when the tangent will cut the time axis, it will always cut the time axis at tau. It should be, because what is the slope of the tangent? Slope of the tangent, is it not dVc by dt? Tangent drawn at what? T equal to 0. So dVc by dt at t equal to 0, already we know it is what? Minus Vc of 0 by tau. That means what? Delta y, for this yellow color straight line, delta y by delta x is what? Minus Vc of 0 by tau. This height is what? Vc of 0. This height must be tau. Only then the slope will be what? Vc of 0 by tau. So in that sense also, one can easily say that this intercept always must be equal to what? Tau. Understood? So first of all, the voltage across the cap, it will exponentially decay with time, starting from its initial value, which is what? Vc of 0. It will exponentially decay to what? 0. When it decays to 0, we say the cap is what? Fully discharged. Okay. And if you draw a tangent to this exponentially decaying curve at t equal to 0, that tangent will always meet the time axis. intercept the time axis at tau, which is what the time constant of the circuit, and you know tau is what? RC. Tau is what? RC. Understood? Yes. So this is about the behavior of a source-free RC circuit. So in a source-free RC circuit, you just have one resistor and one capacitor, and initially some energy will be stored in the capacitor, and all that energy will be completely dissipated by the resistor, so that no energy is left in the circuit. So when the circuit reaches steady state, all currents and voltage will become what? Zero. Okay. So at t equal to infinity, by the way, at t equal to infinity, any circuit reaches what? Steady state. At t equal to infinity, any circuit reaches what? Steady state. T equal to infinity, it means what? After a long time, any circuit reaches what? Steady state. Understood? Yes. So again, for the source-free case, what did we get for Vc of t? Let me write that equation again. So Vc of t is what? Vc of 0 into e power minus t by tau. Now let us write the values of Vc at 1 time constant, 2 time constant, 3 time constant, 4 time constant, and 5 time constant. Okay. So what is the value of the voltage across the cap after 1 time constant? What is the value of voltage across the cap after 1 time constant? When I say Vc at t equal to tau, in place of small t, you substitute what? Tau. In place of small t, if you put tau, is it not e power minus tau by tau, which is what? E power minus 1. E power minus 1 into the initial voltage. Okay. So the value of voltage across the cap after 1 time constant, it will be equal to what? Vc of 0 into e power minus 1. In the same way, what is the voltage across the cap after 2 time constants? That means what? At t equal to 2 tau. Again, in place of small t, you write what? 2 tau. 2 tau by tau is what? 2 e power minus 2. So will it not be Vc of 0 into e power minus 2? And then what is the value of the voltage across the cap after 3 time constants? Again, in place of small t, you substitute 3 tau. 3 tau by tau is what? 3. So will it not be Vc of 0 into e power minus 3? What is the value of Vc after 4 time constants? After 4 time constants, will it not be Vc of 0 into e power minus 4? And what is the value of the voltage across the cap after 5 time constants? It will be Vc of 0 into e power minus 5. Okay. Now, Vc of 0 into e power minus 1, it is what? Approximately 36.7% of the initial value, that is what? Vc of 0. That means after 1 time constant, the value of voltage across the cap will become 36.7 or approximately 37% of its initial value. Yes, after 1 time constant, the voltage across the cap will decay to what? 37% of its initial value. 37%, it means what? 37 by 100, which is 0.37. In fact, it is what? I think 0.368 something, which is approximately what? 0.37. So after 1 time constant, the voltage across the cap will decay to what? 37% of its initial value. And after 2 time constants, it will be what? Vc of 0 into e power minus 2. And this is roughly 13.5% of its initial value. Okay. So after 1 time constant, it becomes what? 36.7%. After 2 time constants, it becomes what? 13.5% of its initial value. And if you wait for 3 time constants, then it will become what? Then it will become 4.9% of its initial value. And if you wait for 4 time constants, then, if you wait for 4 time constants, it will become roughly 2% of its initial value. It will become what? 2% of its initial value. And if you wait for 5 time constants, it will become what? Roughly 1% of its initial value. I mean, these are just numbers, you don't have to remember these values. If you know this, you can find the value of Vc of t at any instant, okay? Vc of 0 into e power minus t by tau. So the point is what? Vc is what? Gradually decreasing with time in an exponential fashion, okay? After 1 time constant, it becomes this much. After 5 time constants, it becomes what? 1%. 1%, it means what? 1 by 100, right? So it becomes what? 1/100th of its initial value. So when Vc becomes what? 1/100th of its initial value, we say the circuit has almost reached steady state. I mean, we won't wait for Vc to become what? 0. Even if Vc becomes what? 2% or 1% of its initial value, we say circuit has what? Almost reached steady state, okay? We say circuit has almost reached steady state. I mean, we won't wait for Vc to become what? 0. It is okay if Vc becomes what? 2% or 1% of its initial value. So the point is what? For Vc to become 2% of its initial value, the time required is what? 4 time constants. And for Vc to become 1% of its initial value, the time required is what? 5 time constants, okay? So in general, the time required by any circuit, by any first order circuit, in general the time required by any first order circuit to nearly reach steady state is what? 4 to 5 time constants, okay? So in general, the time required by a first order circuit, in general, the time required by a first order circuit to nearly reach steady state is what? 4 to 5 tau. How much? 4 to 5 time constants. 4 to 5 time constants, okay? Understood? Now, very often we speak about or we talk about the speed of any circuit, right? We say some circuit is what? Fast, and some other circuit is what? Slow, and so on. So when we say any circuit is what? Fast, it will reach steady state very quickly. When I say any circuit is what? Fast, it is quick to reach steady state, okay? And when we say any circuit is what? Slow, it will take a lot of time to reach what? Steady state. So fast means what? It reaches steady state very quickly. Slow means what? It reaches steady state very slowly. Understood? Now let us say there is some first order circuit which has a large value of tau. There is some first order circuit which has a large value of tau. Is that circuit going to be fast or slow? Large tau, large time constant. Is that circuit going to be fast or slow? Large time constant. We should say that circuit is what? Fast or slow? Slow, right? If the time constant is what? Large, even the time required to reach steady state will be what? Large. It will take a lot of time to reach what? Steady state. That means what? Circuit is slow. You understood? Yes. So how are these? Okay, you are saying slow, which is correct. So how are the speed and the time constant related to each other? How are the speed and the time constant related to each other? Directly or inversely proportional? How are the speed of any circuit and the time constant of the circuit related to each other? Directly proportional or inversely proportional? Inverse. Larger the time constant, more time it takes to what? reach steady state, more time it takes to reach steady state, circuit is said to be slow. So large time constant, circuit is what? Slow. Small time constant, within no time it reaches what? Steady state, circuit is said to be fast. So tau small, circuit is what? High speed, and tau large, circuit is what? Slow. So always speed is what? Inversely proportional to the time constant. So by looking at the time constant, one can decide if any circuit is what? Fast or slow. Or for example, if you want to compare the speeds of two circuits, you just have to compare the two time constants, okay? The one with the smaller time constant will be the faster of the two circuits, okay? Smaller the time constant, faster the circuit will reach steady state, okay? Smaller the tau, faster the circuit reaches what? Steady state, okay? That is why speed and time constant are what? Inversely related to each other. I hope it is clear, okay? So what did we discuss so far? We have discussed the source-free RC circuit, which does not have any independent sources, and in a source-free RC circuit, always the cap will get discharged through the resistor, and after a long time the cap will get fully discharged. The voltage across the cap will eventually become what? Zero. So from its initial voltage of what? Vc of 0, it will exponentially decay to what? 0. That's all, okay? Now let us consider the RC circuit driven by a DC source. Let us consider, or let us understand how an RC circuit driven by a DC source will behave, okay? So what is it? RC circuit driven by a DC source. RC circuit driven by a DC source. So RC circuit driven by a DC source. Let me draw the resistor and the capacitor RC, and this RC circuit is what? Driven by a DC source. Let Vs be the DC source. Let Vs be the DC source. In fact, let me assign a value for the DC source. Let it be 10 volts. Let it be 10 volts. And the voltage across the cap, let it be Vc. Voltage across the cap is what? Vc. And now let me say that this circuit, it also starts at t equal to 0. Let this circuit start at t equal to 0. That means at t equal to 0, this voltage source of value 10 volts is what? Connected across the resistor and the capacitor. So when I say circuit starts at t equal to 0, it means this 10 volt source is what? Connected across the resistor and the capacitor at t equal to 0. You understood? Yes. Okay, here let me also say Vc of 0, it is some 2 volts. Vc of 0, let it be some 2 volts. So what is this Vc of 0? Is it not the initial voltage across the capacitor? So I am saying what? Let the initial voltage across the cap at the beginning of the circuit be some 2 volts. Okay, that means what? Before t equal to 0, something happened to the capacitor due to which the cap got charged to what? A voltage of 2 volts, and then at t equal to 0, we connect the voltage source and so on. That is how you should understand this scenario. Okay, so Vc of 0 is what? 2 volts. Initial voltage across the cap. Okay, now let us understand how the circuit will behave for t greater than 0. What happens in the circuit for t greater than 0? Again, this is very simple. Resistor and the capacitor, are they not in series? Resistor and the capacitor both are in series. Okay, so this is IC, this is IR, this is VR. IR is what? Current through resistor, IC is what? Current through capacitor. VR is what? Voltage across the, VR is what? Voltage across the, this thing, what is it? VR is what? Voltage across the resistor, okay? Now, is it not a single loop circuit? It is what? A single loop circuit. In a single loop circuit, all elements will be in series, they'll have the same current. Having same current, it means what? IR equal to IC. Having same current, it means what? IR equal to IC. Now, if you write KVL around this loop, won't you get 10 volts is equal to what? Drop across resistor plus drop across capacitor. Voltage division 10 is equal to what? Drop across R, which is VR, plus drop across C, which is VC. So when you write KVL, you will get 10 equal to what? VR plus VC. 10 equal to what? VR plus VC. So what is VR in terms of VC? Is it not 10 minus VC? VR in terms of VC is what? 10 minus VC. I hope everybody is able to follow. I mean, these are extremely simple things, okay? VR is what? 10 minus VC. Now, because VR is what? 10 minus VC, current through the resistor is equal to what? Voltage drop across the resistor divided by resistor. Yes or no? Ohm's law, current through resistor is what? Voltage by resistor. I mean, voltage by resistance, sorry. VR by R. And just now from KVL, we found that drop across resistor is what? The applied voltage minus the drop across capacitor, which is 10 minus VC divided by R, which is what? 10 minus VC divided by R. Clear so far? Yes. Now let us do the actual analysis. So once again, I have drawn the same circuit. And initially, what did we take for the initial voltage across the cap? Look at this. Initial voltage across the cap is what? 2 volts. Okay. Initial voltage across the cap, it is what? 2 volts. At t equal to 0. At t equal to 0, VC of 0, it is what? 2 volts. If VC of 0 is what? 2 volts, can you tell me what is the current through the resistor? Current through the resistor, remember, is what? 10 minus VC divided by R. So current through the resistor, will it not be 10 minus 2 by R, which is what? 8 by R. So what is the initial value of the current through the resistor? When the circuit starts at t equal to 0, current through the resistor is what? 10 minus the initial voltage across the capacitor, that is what? 10 minus 2, which is 8. So 8 volts is what? Drop across R, and 8 divided by R is what? Current through R. Now, because the resistor and the capacitor both are in series, this IR is also same as what? IC. IR is same as what? IC. Now look at the current through the capacitor. Is it not positive? Now if you look at the capacitor, IC is what? Entering the plus terminal, and IC is what? Positive. So are we not having a positive current flowing into the plus terminal of the capacitor? For the capacitor, if you have a positive current flowing into the plus terminal, does it not mean the cap will get charged? Yes. So because of the current through the resistor, which will also flow through what? The capacitor, and the current is what? Flowing into the plus terminal of the capacitor, the cap will start getting charged. Okay, so here cap will start getting charged. Cap getting charged, it means what? The value of VC, it will increase with time. Already the initial voltage across the cap is what? 2. So from 2 volts, it will start increasing. From 2 volts, it will start increasing. Now my question would be, what is the initial rate of increase of VC? Rate of increase of VC, is it not dVC by dt? always for a capacitor dVc by dt is what? IC by C. Initial value of IC is what? 8 by R. IC by C, is it not 8 by RC? So what is the initial rate of change of voltage across the cap? It is 8 by RC. Yes. So at this rate, the voltage starts increasing from 2 volts. So when the voltage starts increasing, obviously after some time the voltage will become more than the initial value, which is what? 2. Okay. Look at this. So let us say at t equal to what? T1. At t equal to T1, obviously T1 will be what? Greater than 0. The value of Vc, let it become equal to what? 5 volts. Because from 2 volts it is what? Increasing, right? After some time it will definitely become more than 2. Let it become what? 5 volts. Let it become 5 volts. So if it becomes 5 volts, what about the current through the resistor? What is the current through the resistor going to be? Remember, the current through the resistor is what? 10 minus Vc divided by R. Voltage drop divided by resistance. Plus connected to what? 10 minus connected to what? The voltage across the cap. 10 minus Vc divided by R. Now Vc has become what? 5. So current through the resistor will be what? 10 minus 5 divided by R. Is it not 5 by R? Always the current through the resistor is same as what? Current through the capacitor. Okay. Now also IC, is it not positive? If a positive current flows into the plus terminal of the capacitor, the cap will continue to get charged, because now also some positive current is what? Flowing into the plus terminal. Cap will continue to get charged. Okay. So now we should say cap, it will continue to get charged. Okay. Once again, let me write the value of the rate of change of voltage drop across the cap. Always dVc by dt is given by IC by C, and always IC equal to what? IR, and now IR is what? 5 by R. So is it not 5 by RC? So look at the rate of increase in the, this rate of increase, is it not the rate of charging? Rate of increase is what? Rate of charging. Rate of decrease is what? Rate of discharging. But in this case, cap is what? Getting charged. What was the initial rate of charging? 8 by RC. After some time, when the cap gets charged to what? 5 volts. Now what is the rate of charging for the capacitor? It has reduced to what? 5 by RC. So initially it increases, Vc increases at a much higher rate, then the rate of increase will decrease. Initially it increases much faster, then the rate of increase will kind of decrease. Okay, from 8 by RC you can see it becomes what? 5 by RC. That is what? The rate of increase. Okay, clear so far? Yes. So what is it so far? Initial voltage across the cap is what? 2 volts. Yes. Applied voltage is what? 10 volts. This is 10, this is 2. Clearly the drop across R is what? 10 minus 2, which is what? 8. Whenever you have a voltage drop across resistor, current will start flowing through what? Resistor. Whenever current flows through resistor, the same current will flow through what? Capacitor. Whenever current flows into the plus terminal of the capacitor, the cap will start getting charged. That is why Vc will start increasing from its initial value of what? 2 volts, and after some time Vc has become what? 5 volts, but still the cap will continue to get charged at a slower rate. And what is that reduced rate of charging? It is 5 by RC. So in this way, again after some time Vc will increase to what? Probably 6 volts, 7 volts, 8 volts and so on. Now my question is, when will the capacitor stop getting charged? When will the capacitor stop getting charged? Cap will stop getting charged when dVc by dt becomes what? 0. Yes or no? Cap will stop getting charged when dVc by dt becomes what? 0. dVc by dt becomes 0 when IC becomes what? 0. Yes or no? For the cap to stop getting charged, that means what? Vc should no longer increase. For the cap to stop getting charged, it means what? Vc, it should stop increasing. Vc should no longer increase. That means dVc by dt must become what? 0. Yes. So when will dVc by dt become 0? When IC becomes what? 0. When will IC become 0? When IR becomes 0. Now when will IR become 0? When will IR become 0? Look at this, IR is equal to what? 10 minus VC by R. IR becomes 0 only when VC becomes equal to what? 10 volts. Only when VC becomes what? 10 volts. That means when the capacitor gets charged to what? The value of the applied voltage. When the capacitor gets charged to what? The applied voltage, which is what? 10. This is 10, this is also what? 10. What is the drop across R? 0. Drop across R 0, then the current through R is what? 0. If the current through R is what? 0, then the current through capacitor is also what? 0. Only when the current through cap becomes 0, the rate of charging becomes what? 0. Or the rate of change, it becomes what? 0. Current through cap 0, voltage remains constant, then VC remains at what? 10. That's all. So from 2, it will increase up to what? 10. Once it reaches 10, then the voltage across resistor and the current through resistor and also the current through the capacitor, everything becomes 0. Current through cap 0, then voltage across the cap will stop increasing, it just remains at 10. So what is the voltage drop across the cap doing? Starting from its initial value of what? 2 volts, is it not going to increase up to what? 10 volts, that's all. Okay. Even here the observation is what? It is not like it is linearly increasing from 2 to 10. It will increase exponentially from 2 to 10 because look at the rate of charging. As time progresses, rate of charging is what? Decreasing. Yes, it will become like this and like this. From 8 by RC it has become what? 5 by RC, then it will become what? 4 by RC, then it will become what? 3 by RC, and finally it becomes what? 0. When dVc by dt becomes what? 0, that is when the cap is said to be fully charged. Earlier source free, ultimately cap will get fully discharged. In this RC circuit driven by a DC source, cap will get fully charged. Charged to what voltage? Value of the DC voltage source, that is what? 10 volts in this case. That's all. So what is going to happen if you plot VC versus T? If you plot VC versus T, what is the initial value of VC? It is what? 2 volts, and finally VC will reach what? 10 volts. Yes. And how does it go from 2 to 10? Again it will exponentially increase from 2 to 10. That's all. You understood? Yes. So after a long time, you can see VC, it approaches what? 10 volts. Initial value is what? 2 volts. And finally when the circuit reaches what? Steady state, VC approaches what? 10 volts. So what is happening here? Cap is getting charged through the resistor. Cap is what? Getting charged through the resistor. Okay. So this 2 volts is what? The initial voltage across the cap, and this 10 volts is what? The final voltage across the cap. Okay. And here also if you try to see for this exponential, is it not an exponential increasing function? Yes or no? From 2 volts it will exponentially increase to what? 10 volts. Again for this curve, if you try to draw a tangent for this curve also, if you try to draw a tangent at t equal to 0, yes, if you try to draw a tangent at t equal to what? 0, this tangent, will it not cut this dotted line? Yes or no? Look at this tangent, it will intercept or cut this dotted line, and at what instant, and it will intercept this dotted line, that is what? The final value level, 10 volt level at t equal to what? Tau. Earlier also when we drew the tangent for the exponentially decaying case at t equal to 0, that tangent, it cut the time axis at what? T equal to tau. Now also if you try to draw a tangent at t equal to 0, this will cut the or intercept the final value level. What is the final voltage level? 10 volt level at t equal to what? Tau. I hope everything is clear so far. So source free case, source free without any source, cap will get discharged through the resistor. But in this case where we have a DC source driving the capacitor and so on, cap will get charged to the value of the DC voltage source through the resistor, because remember in between we have the resistor. It is the resistor through which the current will flow, and the same current will charge up the capacitor. So it is the current through the resistor that is responsible for the cap to get charged, because for the cap to get charged, current should flow into what? The capacitor. And the current is actually coming from the, I should not say it is coming, it is actually flowing through the resistor first, then it flows into what? The capacitor, and it is that current which will charge up the capacitor, in this case from 2 volts to what? 10 volts, which is what? The final value. You understood? Yes. If you, let me draw the original circuit again. 10 volts R, C, this is what VC. Now this circuit, when it reaches what? What kind of steady state will this circuit reach? Because 10 volts is what? DC. Because this is what? A DC source. Does it not reach DC steady state? Yes or no? After a long time. After a long time. Because this circuit is what? Because this RC circuit is driven by a DC source. It reaches what? A DC steady state. What is the behavior of the capacitor at DC steady state? At DC steady state, the capacitor, does it not behave like an open circuit? Yes or no? That's all. This is how the circuit will be at DC steady state. Just replace the capacitor with an open circuit. Across this open circuit there will be some voltage drop, that is what? VC at steady state. Okay, this is what? VC at steady state. In fact, what is the current in the circuit at steady state? Because the cap becomes open, the loop becomes open, the current becomes what? 0. Because the current is 0, the drop across resistor will be what? 0. If the drop across resistor is what? 0, the entire 10 volts will it not appear across the open circuit? So what is the voltage across the cap at steady state? It is what? 10 volts, and this 10 volts is nothing but the final value of the voltage across the capacitor. So always the final value is what? The value at steady state. Always final value is what? Value at steady state. Value at steady state. Okay. So the point is what? In general our circuits start at t equal to 0. In general, our circuits start at what point in time? At t equal to what? 0. Yes. Now there are two values. Okay. One is what? Initial value. One is what? Initial value. Assuming circuit starts at t equal to 0, initial value, it is what? Value of the voltage or current at t equal to what? 0 plus. That means what? Just after the circuit starts. T equal to 0 plus is what? Just after t equal to 0. And our circuit starts at what? T equal to 0. So initial value is what? The value of the voltage or the current of interest just after t equal to 0. That is at t equal to 0 plus. You understood? That is the meaning of initial value. The other value we have is what? The final value. Any circuit finally it reaches what? Steady state. Any circuit finally it reaches what? Steady state. And ideally any circuit will reach steady state at what? T equal to infinity. Yes. But practically you cannot wait till t equal to what? Infinity. You can only wait for some time, and that limited time is what? Like 4 to 5 time constant. So practically if you wait for 4 to 5 time constant, the circuit will nearly reach what? Steady state. Okay. Now coming to the other value, which is what? The final value. Final value, it means what? Value of the voltage or current at steady state. When will circuit reach steady state? At t equal to what? Infinity. At t equal to infinity, circuit reaches what? Steady state. So when the circuit reaches steady state, whatever value of voltage or current that you have, that is the final value of that voltage or current. Initial value is what? Value at the beginning. Circuit starts at t equal to 0. Initial value means what? Value at t equal to 0 plus. Be clear about this. Initial value is what? Value of the voltage or current at t equal to 0 plus. Final value is what? Value of the voltage or current at steady state. To find the value of any voltage or current at steady state, you just have to draw the circuit at steady state. And if the circuit reaches what? DC steady state, replace every capacitor with open circuit, replace every inductor with short circuit, find the required current or voltage. That current or voltage at steady state will be what? The final value. Initial value is what? Value at the beginning, that is at t equal to what? 0 plus. So it's all about finding what? The initial value and the final value. This entire first order circuits, it's all about finding these two values, which is extremely simple. Finding what? Initial value, finding final value. Okay. Now the fact of the matter is what? In a first order circuit, driven by one or more DC sources. Every voltage and every current is of the form final plus initial minus final into what? E power minus t by tau. This is the only formula that we'll be using throughout our discussion on first order circuits. Okay, let me read this out. This formula is what? Applicable for, look at this, every voltage and every current. When I say every voltage and every current, not just voltage across the cap or the current through inductor. This formula can be used to find any voltage or any current through any resistor, voltage across any resistor, current through any capacitor, voltage across any inductor, for everything, as long as it is what? A first order circuit. Yes, as long as it is what? A first order circuit. And also